Sequences are a function or functions that list a number of terms, numbers listed out, and you can write them as a general term. And what that means is there's some form of pattern in the numbers so that you can make some kind of equation to see how you get from one number to the next. Now, one of the ways we do that is to write something called a recursive formula. And the recursive formula is when an, or the general term, is given in terms of the previous terms before that. For example, if I give you a sequence, and we'll call it S, and it's 5, 7, 9, 11, 13, and so forth, then I could look at this and I say, well, I'm adding 2 every time, so that's my pattern. I'm adding 2, so I could write the general term by saying that each term, and the n is the position it's in, so this is the first position, this is the second position, so this would be A1, A2. Each general term is the position before it plus 2. And then I would say, and we start out with our A1 is 5. And that way I have a pattern so that I can make my sequence. So all sequences have some form of pattern, and there are some special ones that we're going to introduce and work with throughout. There's the arithmetic, and yes, it's spelled the same as arithmetic, but arithmetic is a noun, arithmetic is an adjective. An arithmetic sequence, and an arithmetic sequence is just like the one we just did. It has a common difference, which we call D. And what it means is you add something between every term. And so the recursive formula for an arithmetic sequence would be the term before it plus this common difference. Now, there are other different kinds of sequences, and the special ones we're going to talk about. There's 5 total. The next one is geometric. And this one has, instead of a common difference, it has a common ratio. And what that means is that we're multiplying between all the terms. So we take each of the terms and multiply it by the common ratio, and we'll get the next term. So in arithmetic, we're adding between them. A geometric, we're multiplying. And those are the 2 most common. Now, there's a couple others that we're going to also discuss. There's something called a Fibonacci sequence. And Fibonacci sequence, what you do is you take each term as the 2 terms before it added together. So for example, if you start with 1, 1, then the next one would be 2, and then we add 1 and 2 and we get 3, and we add 2 and 3 and we get 5, add 3 and 5 and get 8, and so on and so forth. That's a Fibonacci sequence. Then there's a factorial sequence. A factorial sequence is we're taking the position and we're multiplying it times the term before it. So if we start with 1 as our first term, then we could multiply. This is the second position, so we take 2 times 1 and give us 2, and this is the third position, so we take 3 times 2 and that gives us 6. This is the fourth position, so we take 4 times 6 and that gives us 24, and so on and so forth. And that's a factorial sequence. And then the last special one we're going to talk about is called a harmonic sequence, and that's just a reciprocal of the arithmetic. And the way we write that is we take 1 over, and we take the reciprocal of the term before, and then add the common difference of whatever that is. So for example, if we have 1/2 as our first term, then we would take, and our common difference, let's say, is 2. We're adding 2 along the bottom. So if we have our D is 2, then we start with 1/2. We take the reciprocal of that. That's 2 plus 2 is 4. And then our next one, we take the reciprocal of that is 4 plus 2 is 6. So we have 1/6. Reciprocal of that is 6 plus 2 is 8. And so on and so forth. And you see that you're adding along the bottom is what it essentially ends up being. And that's what a harmonic sequence is. So those are the 5 general ones we're going to talk about, especially the arithmetic and the geometric. Those are the big ones. These we'll just mention some and occasionally work with. Now, the other thing we need to look at about sequences is their limit. The limit of a sequence, this is something that's sort of is that very first little introduction to calculus. The way you write that would be the limit as n goes to infinity, so that means the number of terms goes to infinity of the sequence, and it equals some number L. If it equals the number L, then it converges. That means it's getting closer and closer to one thing. If you don't have a number, it doesn't exist, or you're going on and on to infinity, then we say that it diverges. So for example, if we have a sequence 2, 4, 6, 8, 10, and so forth, so we're adding 2, it's an arithmetic sequence, then if we take its limit as n goes to infinity, well, if you think about that as I keep adding 2 and adding 2 and adding 2, you're going to keep on going to infinity. So the limit of the sequence as n goes to infinity would be infinity, and therefore it diverges. But if we have, let's say we have that harmonic one we just looked at, where we have 1/2, 1/4, 1/6, 1/8, and so on and so forth. If you think about this series, or this sequence, as we go on and on and on and on, we're actually going to get closer and closer and closer to 0, because that bottom number is going to get smaller and smaller and smaller and smaller. So this sequence actually converges because it's coming towards 0 as n goes out towards infinity. Now the thing about a limit is it's not, you don't ever actually get to that value necessarily. You might, but you don't necessarily get to that value. It's just what you're going towards. So limits are what you're going towards. So for sequences, what is our sequence going towards as we get more and more and more terms? So you need to make sure you know what a sequence is and how to get the recursive formula by looking at how the term relates to the term before it. And you need to make sure you know the arithmetic and the geometric sequences especially, but also the Fibonacci, factorial, and harmonic, and understand what a limit of a sequence is.